This video is going to quickly cover some different separation of matter techniques. Specifically, we're going to focus on physical separation techniques of mixtures. So mixtures, we know, contain two or more different types of substances that are mixed together. Because of that, we can use different types of physical separation techniques to split them apart. We're going to be basing it on different physical and chemical properties of each of the substances that are in the mixture, and that allows us to then pick the right technique to isolate them from each other. So the first one we're going to talk about is filtration. So this separates by particle size. So depending on the size of the particle, what passes through the filter and what doesn't. This would work great for a heterogeneous mixture, so one where you have a solid that isn't dissolved, so it would have to be a solid, something that is insoluble in water, and we would be able to separate that from the liquid that it's in. So a very common example of this would be sand and water. If you pass a sand and water mixture through a filter, the sand particles are too big, so they'll stay in the filter, and the water particles are small enough and they can pass through. This doesn't work for a homogeneous mixture, something like salt and water, because the salt, if it's completely dissolved, is small, relatively similar to the water particles. They all pass through the filter paper. So this only works for heterogeneous mixtures. Another technique would be using evaporation or boiling off a liquid. So this would be used to separate a dissolved solid from a liquid by allowing the liquid to boil or evaporate from the mixture. So this would work great for a type of homogeneous mixture. So the salt mixed in with the water, if I bring the water up to its boiling point, the water will boil out of the initial mixture. Once all the water has been removed, you're left with the salt that hasn't evaporated or boiled. So that's one way to separate a homogeneous mixture, is using evaporating or boiling. Kind of a similar thought process is distillation. So this is separating by different boiling points. There will be questions that will talk about distillation. You always want to look for an explanation that has to do with boiling points. So this has to do with usually a homogeneous mixture. You could have a heterogeneous mixture as long as it's two or more liquids that are mixed together. So you would basically boil it. You would reach the boiling point of the liquid that has the lowest boiling point. That would boil off, and you'd be separating out the two liquids because they have different boiling points. Chromatography, this separates based on a couple of different things. Has to do with the size of the particles, has to do with solubility, but one big part of this that we'll talk about later this year has to do with the polarity of the substances and how well they attract each other, depending on what solution you use and what you're trying to separate out. So this is a good one for a homogeneous mixture. There's two other less common ones that I'll just mention. So something called crystallization. So you have a mixture, a dissolved solid that's in a solution, and then you change the temperature, which will change the solubility of the solid, and then you can remove the solid that's been recrystallized in your solution. And then magnetic attraction, this is just simply separating by differences in magnetism. So if you have a mixture and you have one thing that's magnetic and ones that are not, you can use a magnet to pull out the magnetic substance from the non-magnetic ones. So that's all you need to know right now for separation of matter.